Welcome to an interesting question I came across from this geometry textbook, Houghton Mifflin, and I believe this is page 302, problem number 38. If the wrench just fits the hexagonal nut, what is the value of x? So let me bring this a little bit tighter. Let me move this out of the way here so we can just focus on this problem here. And what we got to do is we got to see that we need to find the value of x right there. And we see that 1 centimeter is this length right here. So what I'm going to do is I'm going to snip out this little piece and make it bigger so we can work on this problem. And now, yes, much bigger, a lot easier here. So as we can see from the problem, we know that this length right here, this length here is 1. So that's 1. We're trying to find the length from here all the way to here. That's x, and that's from this problem right here. So this length to this length, that's x that we're trying to find. So what I see here is I notice that if I cut this across, let me make this a little bit wider. Each little mark here I'll make a little bit wider. So I see here, by the way, if you want to solve this, you should press pause because I'm going to go through my whole thought process here. So if I do this here, we can see that 360 degrees all the way around, and it's divided into 1, 2, 3, 4, 5, 6 different sectors. So if it's 360 degrees divided into 6 sectors, that means that each of the sectors is 60 degrees. So that means that each of these is going to be 60 degrees. Okay, so if that's 60 degrees, and if I draw a line directly from the center to the middle, that would be an altitude right there. Let me do this like this. That would be probably a little bit easier. So that's an altitude. So, and if that's cut in the middle, then that means that this little length, or this little angle, I should say, is 30 degrees. Boy, that's hard to see. Let's try again with black. 30 degrees right there. That means that this little area here is going to be 60 degrees. Okay, let's zoom in a little bit more on that and get in there a little bit. So we have 30 degrees, 60 degrees, and so on. And then we also know that if the entire length, if this whole length is 1, then halfway across, that means this must be 1/2 right there. Now, as we know from 30, 60, 90 degree triangles, so if I draw this here and I have 90, and if this were the 60 degree and this is the 30 degree, then we know that in any 30, 60, 90 degree triangle, we have, this is the length of 2. This is twice the size of the 30 degree angle. And this is square root of 3 times the short side. And so we have this here. So now what that means is, if we relate that to this, that means that this is half the size here. So if this is half the size, then this 2, that means that this is a 1. I mean, that doesn't really matter all that much, but that would have to be 1. And if this were half, then this square root of 3 would have to be half right here. So this would have to be the square root of 3, but half of that. And so we come back to what is the answer here. Well, what we would have is, I'm going to zoom out just a wee bit and show you that to remind you that, okay, we're trying to find this full length right here. So that means it's from here all the way to the other side. Well, This is the square root of 3 over 2, and that means the other side also, this side right here, that also would have to be the square root of 3 over 2. Well, if you take the square root of 3 over 2 plus another square root of 3 over 2, that's just the square root of 3 because it's 2 halves of them, right? So what is the final answer? It is the square root of 3. That is the length of x. Kind of interesting, huh? Thanks for watching.